All right, so what we're going to do today is figure out the coordinates of the special angles that you memorized. So you know where these things are in the unit circle, and you'll find that these coordinates are going to have great significance in the next couple days. So there is a reason for us learning this, but you want to have an understanding of what these numbers mean. So today you're not going to get that full understanding. You're just going to see them as coordinates, and they're not going to mean anything, but give us a couple days and you'll see how awesome they really are. Now, obviously with this notes, you know, if you were in class, we had sticks for you to use and measure and things like this. So you can't really, I can't really do that on a video. But here's what I want you to understand. So if the radius of the circle is 1, remember when you're in a coordinate system, like back when you first learned to plot points, you know, if you plotted a point here and you gave its ordered pair, you're really telling what is the x and what is the y of that point. So that's what you're actually doing. And so I want you to understand that with these coordinates, I'm doing the exact same thing. I'm telling an x coordinate and a y coordinate. So if the radius, if you look at the circle, if it says that the radius is 1, then that means from here to here is 1. And from here to here is 1. So with that being said, I think the quadrantal angles, you should say, okay, I could tell you the ordered pairs. If I plotted a point on a Cartesian and pointed it here and said that this distance was 1, what would you say the ordered pair of that point is? And you'd say, well, that's 1, 0. 1 in the x and 0 in the y. Correct? So I think that's pretty easy. If I ask you this top one right here, you'd say, well, that's 0 in the x and 1 in the y. What about over here? It kind of got cut off. It's hard to fit in a full thing there. That's okay. We'll have space. So this guy, what would you say his ordered pair is? Well, it's -1 and 0. And down here, we're at 0, -1. So those ordered pairs shouldn't be that hard to memorize. It kind of is just logical. I mean, you can plot points on a Cartesian. You could, coordinates, you could certainly plot them on this one as well. So the issue is these middle ones. And here's where, of course, with the sticks, you were able to measure and do and all that kind of stuff for you to understand. And being that you don't have that, I'm going to have to kind of teach it in a different way. So I'm going to come back to this screen, but I'm going to go to this one. I'm going to develop these numbers first, and then we'll come back to this. So let's just think back to a 45, 45, 90 triangle. And so when you have a 45, 45, 90 triangle, do you remember the special relationships between those sides? And hopefully what you remember is, if I were to label these with A's, because this is 45 and this is 45, so of course these are going to be the same. And my geometry people, what's going to be this side is going to be the square root of 2a. So what do we know? So let's see what we can figure out. Okay, so here's the deal. What you have to realize is that this right here, if I could draw my coordinate, and this is not going to be a good circle because I can't make it that big, but you need to understand that this is really bad, is in the unit circle. And so this radius right here, this is the radius of the circle. The x and the y are not, but the radius is the square root of 2a. So if the square root of 2a is 1, then that means a is 1 over the square root of 2. Now here's the deal. 1 over the square root of 2, it's an okay number, but most of the time in multiple choice answers, you will have to rationalize. And so we're going to make you do that and because most books make you rationalize. And what I mean is they don't like to have a square root in the denominator. So in order to get rid of that, I am going to multiply by, of course, 1. That's the only thing I'm allowed to multiply by. And I would get the square root of 2 over 2. So you need to understand that 1 over square root of 2 and square root of 2 over 2 are the same value. This is the one that you're going to need to write. So we do want you to rationalize when you're writing these coordinates. So if a is square root of 2, do you notice that the x and the y have the same value? So let's go back to page 1. If you go back, that means, look guys, we just figured out, isn't 45 degrees, the 45 is the middle one? You figured out that the x and the y were square root of 2 over 2 and square root of 2 over 2. And doesn't that look visually about right that the x and the y are the same? Now, let me ask you this, sweet, sweet children. If this is the 45 over here, again, the whole idea of reference angles, yes, this whole thing is 135, but that means the reference angle right here is 45 degrees. Wouldn't I have the exact same triangle as I did here, with this being 45 over here? So what does that mean? That means those lengths are the same. So if I ask you the ordered pair for 135, wouldn't it have the same values, square root of 2 over 2 and square root of 2 over 2? But what's different? Well, I don't know. Let's see. If I ask you to label a point in quadrant 2, are you going to tell me it has a positive x and a positive y? No. You're going to say, silly goose, that x is negative. So it's negative square root of 2 over 2 and square root of 2 over 2. So that's the cool thing. Yes, you can use the reference angle to find those links, but you have to think about where it is in the quadrant to get the signs, S-I-G-Ns, the signs, correct. Now, I bet you, smart children, could now write the ordered pairs of these other ones because, again, all the 45s, they're the same triangle. It's just a matter of positive, positive, and in quadrant 3, the x is negative and the y is negative, and in quadrant 4, positive x, negative y. Isn't that so tremendously cool? So they all have the same. Now let's look at the 30s and the 60s. Now let's just look visually for a second. If we're truly writing this ordered pair, you're writing the x and the y. So let's just do that one, and then over here, well, let's just say that one. So which number do you assume to be, which is going to be a bigger number, the x or the y when I'm doing a 30-degree angle? Well, which is longer, the x or the y? Well, the x. So you're going to have the longer or the bigger number here and the shorter number there. Let's look in the 60-degree. If I did a 60-degree, here's the x, here's the y. Which one of those is going to be which one is going to be longer? Well, don't your eyes kind of tell you that? The x is short and the y is long. Now let's figure out what those numbers are. And I am going to do a 60-degree. So by the same, kind of in the same way, again, let's do our geometry. Our geometry, I'm going to draw it real small right here. So if we have the unit circle, we have our 60-degree angle here. Okay, so that is really small. So we have 60, and what do we know? We know that is very little. That is a 30-degree up top, which is that angle up there. We know across from the 30 is A. We know across from the 60, do you remember that one? That's square root of 3A, and across from the 90, that's 2A. So that's our special relationship between the 30, 60, 90 triangle. Which one of those is the radius? Well, the radius of the circle is this one. So if 2a is equal to 1, then a is equal to 1/2. And then the square root of 3a is going to be square root of 3 times 1/2, which is square root of 3 over 2. So looking at our picture, x, this is x and this is y. So for an ordered pair of the 60, the x is going to be 1/2, and the square root of 3 over 2 is going to be the y. Doesn't that make sense? Let's go back. I know we're flipping pages a lot. Let's go back to this one. Didn't we say that the x was the short one and the y was the long one? Well, look at these two numbers. We have 1 over 2 and the square root of 3 over 2. Which number is bigger? Well, square root of 3, I mean, they both have the same denominator of 2. And so the square root of 3 is bigger than the square root of 1, or 1. So the square root of 3 over 2 is longer. So it makes sense that the x coordinate is the 1/2 and the y coordinate is square root 3 over 2. You have your short x and your long y. Now, friends, here's the absolute coolest thing about this. What would happen if I switch? Where do the coordinates of a 30-degree angle come from? Do you understand that if I switch that on the circle and I did a 30-degree, my 30 would be here, my 60 would be here. So do you notice that these two things would just flip? So what do you think the coordinates of a 30-degree angle are? Long in the x, short in the y. They came from that same 30, 60, 90 triangle. And so right here with the 30, if I drew that, you have your long and you have your short. If you look at the pink, it's long. I wish I had a third color. Let's see if I can get a third color in here. That would be really nice. I have long in the x and short in the y. Now, let's see if you can fill out the rest of this. Again, it shouldn't be hard. If you know quadrant 1, you know every single one. Because all of these guys, if you think of long and short and x and y, long in the x, short in the y, it's just the x is going negative, so it's going to be like this. This point, long, short, so it's square root of 3 over 2 and 1/2, but you're going left and down, so they're both negative. You're in quadrant 3. In quadrant 4, square root of 3 over 2, negative 1/2. And that's the ordered pair. Now, I didn't fill out the rest of the quadrants in these guys, but I bet you now can. So it's negative x, positive y. Notice the pi over 3's. Y'all, if you forget, visualize it. If you know where they are in the unit circle, understand what these coordinates are. It's an x and a y. Which one is longer? So you have negative 1/2. I want it to be in purple. Negative 1/2 and negative square root 3 over 2. And 1/2 negative square root 3 over 2. And now you have your unit circle and your coordinates all filled out, but you understand where you're coming from. So what your homework is without looking at the circle, write the coordinates of these angles. Now, when I say without looking at the circle, I'm not saying, okay, you're going to have to just simply memorize and don't know. That's not what I'm meaning. I'm meaning we obviously just, what I don't want you to do on your homework is have this in front of you and go, oh, okay, here's 150 and write them down. I want you to start from scratch and do it like this. So I'm not saying don't think of the circle. Here are the steps that I want you to do. I want you to mark where 150 degrees is. So we've done that where you go, okay, where is 150? Okay, 150, that would be, well, this is 180, so 150 is right here. Okay, it's that special angle there. What would the coordinate of that be? Well, it's by the x, so it's going to be long in the x and short in the y. So again, the pi over 3s and the pi over 6s are ones that people, and I'm not done with that coordinate yet, so don't think that I am. The pi over 3s and pi over 6s are the ones that people get confused because they're flips of each other. But if you visualize where it is, you shouldn't miss it. Is it longer in the x or the y? If it's closer to the x-axis, it's going to be bigger in the x. Now then the last thing, but you cannot forget the sign. You're in quadrant 2, so in quadrant 2 you have a negative x and a positive y. So that's what I want you to do, that right there. Okay? So let's do 5 pi over 4. Again, some people, I'm just drawing a circle every time. You could draw one circle and mark what you need, but whatever you want to do. So the pi over 4s, remember those are the ones right in the middle. You could almost memorize and go, oh, those are the ones, that's square root of 2 over 2 for both coordinates. They have the same x and y. Now the only thing is, where is 5 pi over 4? Remember the pi over 4s go by odds, so 1, 3. So this is the one I need. I know the ordered pair is square root of 2 over 2, square root of 2 over 2. And you just kind of start memorizing that for the pi over 4s. I'm in quadrant 3 because, again, my angle's down here. So in quadrant 3, both of those are negative. Done. Quadrantal, 270. Mark it. Well, what's the ordered pair? 0, -1. So your homework, it's hopefully you get very fast at it. That's the key, is you've got to get these where you memorize and you know where they are and you can go fairly quickly. Let's do 7 pi. Where's 7 pi? Well, these are the even pies. These are the odd pies, right? So 7 pi is going to be over here. So 7 pi, what's the ordered pair? -1, 0. Good, good, good. -120. Let's think about where that is. Again, you can do two things. Some people are very good visually. They go, okay, I can just go in a clockwise direction from this and go clockwise 120. Some people don't like negative angles and they say, you know what, I'm going to use the idea of coterminal angles and I'm going to add 360 to that, and I would get 240. So whichever way you like better is fine, but one way or the other, you mark. That's not a quadrantal. My pen is just being kind of weird. So it's the pi over 3 that's down there. And so what's the ordered pair? Again, think of the x and think of the y. It is short in the x and long in the y. You're in quadrant 3, so both negative. -5 pi over 3, again, same kind of song. Some people go, I'm going to go ahead and add the 2 pi, which in this case 6 pi over 3. So that would be pi over 3. Well, that's an easy one. That's in quadrant 1. So both positive. X, Y, short in the X, long in the Y. And those are my ordered pairs. So that's what you're going to be doing on the homework. So man, I cannot tell you the importance of today's lesson, getting these ordered pairs down, understanding where those numbers come from. Not that you're going to have to derive them like we did here. That's not what I mean by understanding where they come from. But when I say 1/2 square root of 3 over 2, why is it positive, positive? Why is the x short and the y long? When I put in the negative, why is it negative? It's because where it is. So you have to make sure that you understand that and really practice that before we move on. Okay? All right, peace out.